Welcome to the AI Weekly Briefing. This week we're digging into a really fascinating disconnect that's happening in the industry. On one hand, we have a staggering 95% failure rate for enterprise Gen AI pilots, and on the other, OpenAI is planning infrastructure on a trillion-dollar scale. We're also going to cover new state-of-the-art performance in clinical diagnostics, a really clever method for measuring model memorization, and the geopolitics of NVIDIA's new export-compliant chips. So let's get into the technical details. So here's how we're going to break it down this week. We'll start with the reality of enterprise AI adoption. Then we'll look at some real breakthroughs in applied AI. After that, we'll dive into new research on model memory and safety. From there, we'll zoom out to the infrastructure and chip competition. And finally, we'll touch on AI's growing human and environmental footprint. Let's start with the enterprise, because a pretty big reality check is underway. The central story this week, really, is this profound disconnect between the current practical reality of enterprise AI and the massively scaled future that its biggest players are architecting. Let's just start with this one number, because it really sets the stage. 95%. A landmark new report from MIT finds that a staggering 95% of corporate generative AI pilot programs are failing to generate any revenue. So, what's going on here? Well, the diagnosis from this MIT report, which is called the G&I divide, is absolutely critical. They're saying the bottleneck isn't the quality of the AI models, it's an enterprise learning gap. The data shows a really clear mismatch. Most of the funding is chasing sales and marketing use cases, but the highest ROI, that's coming from back-office automation. The report also suggests that trying to build these things in-house is often a costly mistake, and leveraging specialized third-party vendors is proving to be way more effective. And then, in just stark contrast to that reality, Sam Altman laid out OpenAI's roadmap for what comes after GPT-5. And wow, this vision is less about just making the next model a little bit better and more about building a global tech conglomerate. We're talking hardware devices, consumer apps, and even fundamental infrastructure like data centers and energy. This level of ambition is going to require just massive, massive capital. And Altman even hinted that a public offering might be on the horizon to fund it all. While that broad enterprise adoption is struggling, the technical capabilities of these frontier models just keep advancing. Let's take a look at where they're actually demonstrating concrete, measurable success in some really specialized domains. A prime example is this new study from Emory University benchmarking GPT-5 in clinical diagnostics. Now, the performance here really hinges on its advanced multimodal reasoning, specifically its ability to correlate messy, unstructured notes from electronic health records with high-resolution medical imaging. It didn't just outperform GPT-4o and human specialist on accuracy, it was better at synthesizing differential diagnoses from conflicting data points across different modalities. This really suggests a significant leap in cross-modal attention mechanisms.
And you see this trend extending to other complex domains. The Alzheimer's Prize is really notable because it's focused on developing agents that can autonomously generate hypotheses from longitudinal patient data. Meanwhile, NASA's new Surya model, well, it gets a 16% accuracy gain in predicting solar flares by using a transformer architecture to analyze magnetomogram and EUV imaging data. That's a big departure from the older CNN-based approaches. This impact is crystal clear in developer workflows. A new Google Cloud study finds that AI adoption in game development has now surpassed 90%. And the key applications here are things like procedural content generation, code completion, and, maybe most impactfully, automated playtesting agents that can simulate thousands of hours of gameplay to find those really obscure edge case bugs. And this integration is now hitting mainstream enterprise tools in a big way. Microsoft is being very strategic here, deploying models based on the complexity of the task. So you have a smaller, more efficient GPT 4.1 mini that powers the new Copilot function in Excel for structured data analysis. But the full, powerful GPT-5, that's reserved for Outlook's Smart Mode to handle the much more nuanced task of analyzing and drafting emails. Okay, so with all these expanding capabilities, the focus naturally sharpens, right? We start asking, what's actually happening inside these models? And how do we implement robust safety guardrails to manage their behavior?
A really key paper from Meta and Google this week gives us a much more precise way to measure data memorization. They've moved beyond simple extraction attacks. Their method uses the model's negative log likelihood on subsets of the training data to create a memorization score. And here's the crucial finding. This score scales linearly with the parameter count. This gives us a quantitative tool to actually study that transition from pure memorization to real generalization as models get bigger.
Now, on the safety front, this question is driving some really novel experiments in model self-regulation. And Anthropic is taking a particularly interesting approach. They've engineered a mechanism that allows Claude to autonomously terminate a conversation. Now, this isn't just a simple content filter. The system is actually trained to detect escalating patterns of harmful queries. Once it detects one, it triggers a protocol and just ends the session. It's a key experiment in what they're calling model welfare research, basically exploring whether a model can be trained with internal safety behaviors instead of just relying on external wrappers. This all ties into a broader warning from Microsoft AI CEO Mustafa Suleyman. He's cautioning against what he calls seemingly conscious AI, arguing that marketing these systems as personalities could lead to what he calls AI psychosis among users. He's urging the industry to focus on building AI as a tool for people, not as a replacement for a person. Of course, none of these models run in a vacuum. The underlying hardware and energy infrastructure has become the central theater of geopolitical competition in AI. It's where the real action is. To understand the scale, just look at this number, 4.5 gigawatts. That's the planned electricity consumption for the new data center capacity OpenAI is building with Oracle. This massive power draw is a key component of its $500 billion Stargate supercomputer project. And that kind of demand just fuels a geopolitical feedback loop. We're seeing this strategic cat-and-mouse game play out between U.S. export controls, which target not just chips, but advanced packaging and interconnect tech, and China's multi-pronged response. They're mandating security reviews, funding domestic champions, and pressuring suppliers for compliant workarounds. And you see NVIDIA trying to navigate this incredibly complex landscape. They're engineering a new chip, the B30A, specifically for the Chinese market. It's based on the new Blackwell architecture, but it's designed to comply with U.S. export rules. But its path to market is, well, it's far from certain, as it now faces China's new domestic security review process. And finally, this unprecedented scale is forcing a reckoning with AI's impact on both human capital and, of course, the environment. On the human side, Meta has made a pretty significant move. They've dissolved their AGI Foundations team and put in place a broad AI hiring freeze. This really signals a major strategic consolidation after a period of just incredibly aggressive talent acquisition. It suggests the industry might be entering a new, more mature phase. Google also released a report on Gemini's environmental footprint, but its methodology is being heavily scrutinized. Critics immediately pointed out a major omission. The study calculates the direct water usage for cooling the data centers, but it completely omits the much larger water footprint of the power plants that supply the electricity in the first place. It's a classic case of focusing on Scope 2 emissions while basically ignoring the larger, indirect Scope 3 impacts. To really put OpenAI's 4.5 gigawatt power requirement into perspective, that single project's planned annual electricity consumption is on par with, and in some cases even exceeds, the entire annual consumption of developed nations like Denmark. This is the new scale that we are operating at. And all of this leaves us with a critical and I think pretty urgent question for the industry. As the resource demands of AI, for data, for talent, and for raw power begin to rival those of entire nation-states, who is ultimately responsible for governing its impact?